Hi lads, this is a short video explaining how to do the question from today's class. It tells us figure 18.78 shows the plan of a shell structure in the form of a hyperbolic paraboloid. Curve DBA is semi-elliptical in plan. Curves DE and BF are found by extending the surfaces ABCD until it meets ground level. Draw the plan elevation of the structure and project the end view. For this question, it tells us B and D are on the ground, and that A and C there's actually no heights. So for the question I want you to set A to 25 meters and C to 10 meters. To actually start the question, I draw my plan outline showing A, B, C, D, and I divide up my four sides into 5 equal parts. Because the length of AD and AB are the same, I just divide up this half here and then just taking my points down. And then for this side here, I've divided up DC and then projecting my points down because CB is the same length. After that, I connect my elements together, and I also draw my connecting lines A, B, C, D just in dashed. We're told already that the curve A, B and D is semi-elliptical, so I just use the concentric circles method to actually plot points on the curve, and then I just colour in my elements green and blue going in the opposite directions, and this will help me later on in the question. For the elevation, I told you already that A we're going to set as 25 meters above the ground, and C we're going to project as being 10 meters above the ground. And once again, we connect A, B, C, D together using dashed lines. And there I'm showing how to take my elements up into the actual elevation. So you can see, for example, A goes up to there. If I follow A along there, A connects up to there as well. Notice how I've only used green above. Green and blue will overlap each other, but just for the sake of it, I picked green. After that, I can start projecting the points on my curve where the semi-elliptical curve takes place. So what we do is we extend our elements out past our actual lines A, B, C, D. So for A and B, we extend our green element out to hit the actual curve. We extend it out once again to hit the curve, extend it out to hit the curve, extend it out to hit the curve. And we do the exact same on the blue side as well. What we then do is we take, for example, this point up here, we take it straight up, and what we do is we extend the actual element in the elevation as well. So for example, C here, we extend it out to hit that line we took up there, and that gives us a point on the curve, and we repeat that for all four elements there, and that'll give us our curve going up this way. What I've then done is I've shown in plan how to get my points on the curve on the bottom half. So we're told in the question the elements extend to hit the ground, so I just use blue for this half here. So you can see blue extends out, and where the blue extends out to hit the ground there, I take it down to hit my extended point there. I repeat it for this point here. I extend it out, I take it down, and then I get my point here, and I can draw a neat freehand curve then in the bottom half as well. And there I've shown now how to actually just draw in the curve. So just drawing in my points all connecting together. And I've also copied my curve over on the opposite side here. You can just very simply take the distance on your compass halfway and step it across, or what I've done is just extend the elements out again and drop my points down, this time on the green side.